Welcome back to Elements of Chemistry tutorials. We're going to continue our discussion of the periodic table today. And this is the last in the periodic series. We're going to talk about trends. And to understand periodic trends, you've got to understand Coulomb's law. Coulomb's law basically is opposite charges attract and like charges repel. So here we've got two positive charges. They're going to repel each other. If we have a positive and negative, they're going to attract each other. And the distance matters. So the amount of charge matters and the distance matters. If we have more positive charges, right here, it's going to pull with a greater force of attraction toward those positive charges. That's a key. And the more positives we have, the more it's going to be attracted to that positive center, that negative charge. Now, if we increase the distance, the less it feels. I find it sometimes easier to think of Coulomb's law in terms of magnets. You know how two north poles of a magnet will repel and a north pole will attract a south pole? We put three magnets with their north poles all pointing toward that negative south pole on a third magnet, fourth magnet, it's going to drag it closer. So key equation here. Not that we're going to ask you to calculate it, but you need to understand that this force is due to the separation of charges, the amount of the charge, and how far apart they are. So the equation tells us the force of attraction or repulsion is dependent on the amount of the charge and the distance it separates them. The greater the distance, the less force of attraction or repulsion. So what does this mean in terms of the atom? The more protons you have pulling on an electron, the greater the force of attraction. Remember, the protons are all grouped in one place, that nucleus. The electrons are independently going around the cloud. So we're talking about how that group of protons is pulling each independent electron. The ones that are closer to the nucleus are going to feel more force than the ones that are further away. And that is the key trend for atomic radius. And if you understand radius, it'll make sense. As you move down the row, you're adding a layer of electrons. Okay? Each time you move down, you add a layer of electrons. It's getting further and further from the nucleus. So the largest element on the periodic table is here at francium. It has only one outer electron, because it's a group one, so one outer electron. And it's that outer electron is farthest from the nucleus. Now, as we move across the period, as we move across, we're adding protons, our Z effective. That's the nuclear charge. The nucleus technically gets stronger as you move across, pulling those electrons in tighter. So if francium was the largest, diametrically opposed is helium, this is going to be the smallest because it has the most nuclear charge for that energy level. So xenon is going to be much smaller than, say, cadmium because it's got more protons in its nucleus acting on that energy level. So atomic radius is a key point here. Now, ionic radius. When an atom becomes a cation, it loses its outer electrons. So if we're looking at, let's just say sodium here. Sodium, when it becomes an Na+1, it has lost its 3s1 electron, but it still has those extra protons. So that Z effective has increased. That's going to be drawing those in tighter. So cations become smaller. So cations are smaller than the neutral atom. Now, when you get over here to an anion, anions have gained an electron. Remember, like charges repel? So that electron cloud's got to expand to take that in because of electron-electron pair repulsion. So anions get larger because you've added an electron. It's made that cloud increase in size. So anions expand, so they're larger than the neutral atom. There, first two trends, and probably the most important. Now let's talk about ionization energy. Ionization energy is the energy required to form an ion. In other words, to remove an electron from a gaseous element. Okay, so the energy is always positive and it increases with each ionization. So what's the easiest element to take an electron away from? Well, look, go down here, francium. That's got to be the easiest. That electron is so far away from its nucleus that it is easier to remove an electron. So it's harder to take an electron away that's closer to that Z effective, closer to the nucleus. The hardest element to take an electron away from is over here at the noble gases, and helium primarily. That's where the highest ionization energy is because it's got a full, stable electron configuration. Keep that in mind. And it's tight. Those outer electrons are closer to the nucleus. I think this table really does show it well. The larger the atom, the easier it is to remove an electron because of orbital distance. We like to use that term shielding. The inner electrons are protecting the outer ones. The smaller the atom, the harder it is to take it away from. Now I want you to notice this trend. Okay, so it's harder to take it away from noble gas. But see, it gets easier, and then there's this little peak right here. Easier, easier, peak right here. What's happening at that peak? Well, that is when you've got that each of the p orbitals is full. It has an electron in it. Remember, half-filled orbitals are more stable than partially filled orbitals. So what's going on with this peak right here? That's that S. And here, an S being full. Transition metals also have some weirdness going on with them. Remember, D's are going to fill before. So you've got all that going on here. So think about the periodic table. The hardest to remove an electron are over at this side of the table, your noble gases. The easiest, these alkali metals, they're practically throwing their electrons away. So the trend is going to point across and up for the most difficult to remove the electron away from. Also think, okay, beryllium's kind of hard to take the first electron away. It's much easier to take the second electron away because that is now an S1 configuration. It's a lot easier to go back here. If we were looking at neon, difficult to take an electron away from, a little easier for the second ionization. Just think going back an element. Easier. Gets harder again when you're taking out, now this would be its fourth ionization. So you can kind of backtrack on your periodic table. Electronegativity. This one confuses a lot of people. Electronegativity is the ability of an atom to attract electrons to itself. It has to do with strong nuclear force, small radius. Obviously, the noble gases aren't going to want to attract electrons to themselves. They have a full configuration. But these halogens, they're so reactive because they need just one more electron to be stable. Their nuclear charge is effectively going outside its radius to attract electrons to it. So this trend increases as you approach fluorine. And it is very much the same trend as ionization energy. It's going to increase as you move over and increase as you go up. But for electronegativity, we're going to take these halogens, the noble gases off the table because they're not going to be attracting any to it because it has a full configuration. Metallic and non-metallic character. Character is a measure of an atom's ability to form an ion. So as you can see from ionization energy trends in the metals group, metals easily lose electrons and halogens easily gain them. So the most metallic character is going to be the atom that holds its valence electrons the weakest. Good old francium, right here. It is our most metallic. And the one that's going to attract electrons to it the most is over here at fluorine. It's going to be attracting its electrons to its the most. So metallic character is how easily an atom loses an electron. Non-metallic character is how easily it attracts an electron. Trends are confusing. You might have to go over these a few times. There's lots of great periodic tables that will give you like all the trends on one. Go ahead, look them up. We didn't have time for them here because remember, we're keeping this short, sweet. So once again, I hope this helped you out some. Join us again for Elements of Chemistry tutorials. Our next set of videos, Chapter 8, will be talking about bonding and moving then on to nomenclature. As always, I hope you have a wonderful day. Stay safe, be kind, and have a great tomorrow. We'll see you back on Elements of Chemistry.